A man of 50 kilogram mass is standing in a gravity free space at a height of 10 meter above the floor. He throws a on of 0.5 kilogram mass downward with a speed of 2 meter per second. When the object reaches the floor, the distance of man above the floor will be. So this question is basically related to collision and conservation of momentum. So over here we are considering that a man of mass which is 50 kilogram is standing in a gravity free space at a height of 10 meter above the floor. So with respect to this floor, we can take this distance as equal to nothing but 10 meter. He throws an object of 0.5 kilogram downward with a speed of 2 meter per second. So this is 0.25 and it is projected with a velocity which we can take as 2 meter per second. When the object reaches the floor, the distance of man above the floor is. So over here it is given that gravity free space, that means there is no force exerted or there is no external force. So we can say that as there is no external force, we can conserve momentum, or you can say that as the net force acting on the system is equal to 0, acceleration of center of mass is equal to 0, velocity of center of mass is equal to 0, or displacement of center of mass is equal to 0. So we can find out what about the displacement of this 50 when this 0.5 reach the ground. So after some times we know that as 0.5 is going to reach the ground. So this was the initial position. So this 10 meter is a displacement which is happening to that 0.5 kilogram object, and man of mass 50 kilogram will reach somewhere over here. We don't know its displacement. Let's say I'm just taking it as displacement of man, and Rm is to find out what about the displacement of man. So we can use the concept of displacement of center of mass, that is equal to m1 into displacement of first object plus m2 into displacement of second object divided by total mass of system m1 plus m2 should be equal to 0. As the external force acting on the system is equal to 0, acceleration of center of mass should be 0, velocity of center of mass should be 0, or displacement of center of mass should be equal to 0. So we can write this m1 s1 plus m2 s2 should be equal to 0. So we can write take it as this m1 the mass of man into displacement of man vector plus, or s equal to minus of mass of that object into displacement of that object. So we can find out the displacement of man as equal to minus of displacement of object into displacement of object into mass of object divided by mass of man. Now mass of man is given as 0.5 into displacement of object, that it is in downward direction. If I am taking displacement in downward direction as negative, so we can just write as minus 10, and the mass of man which is given as something but 50. So we can observe that it is 5 divided by 50, or you can take it as nothing but 0.1 meter is a displacement of man, and we are getting a positive value. That means man is displaced in upward direction by a distance of 0.1. So initially the man was at a height of 10 meter, now displaced by an additional 0.1 meter in upward direction. So the distance of man from the surface will be equal to 10 plus 0.1, which we can take as 10.1 meter.